Hi, today we are dealing with section 4.4, which is permutations when objects are identical. So in the last section, we dealt with if each object was unique. Today we are going to look at what happens if some of the objects are the same. So for permutations in which we have identical objects, so for example, if you're arranging 6 red plates and 1 blue plate, we can use the formula n factorial over r factorial, where n is our total amount of objects and r is our amount of identical objects. So for example, there are 7 plates. We have 3 are white, 1 is black, 1 is blue, 1 is red, and 1 is yellow. How many different ways can they be stacked? So we have the formula from a previous page. So we've got n factorial over r factorial is equal to, well, we've got 7 items total, so it's going to be 7 factorial. And then we have 3 identical ones that are all white. So we'd have 7 factorial over 3 factorial. Now that's the same as 7 times 6 times 5 times 4, which gives us 840. Now this is how we would do it if we only have one object that's repeated. But what if, for example, we had 2 black plates, 4 blue plates, 6 red plates? How would we deal with that? That's what we're going to look at next. So if we have multiple items that have identical copies, our formula becomes n factorial over n1 factorial, n2 factorial, n3 factorial, and so on. So for example, to get home from work, you have to walk 10 blocks, 4 to the east and 6 to the south. How many possible routes are there for you to take? Now for this, essentially, we're going to use n factorial over n1 factorial times n2 factorial. So we have to walk 10 blocks total. So we've got at least 4 to the east and 6 to the south. So that's 4 plus 6, which also gives us 10. So that gives us 10 factorial over, and then it doesn't matter which one's n1 and which one's n2, but we've got 4 there to the east and 6 are to the south. So you've got 10 factorial over 4 factorial times 6 factorial. And that gives us 210. So if we have permutations that have identical objects, we cannot use our NPR formula from a previous section. Instead, we have to use this formula here.